All right, so let's see what we got. All right, so motion and force, okay? We know what motion is. Kind of what we're talking about today is force. All right, what is force? All right, uh, and this is the definition of force. Okay, force is an action exerted on a body in order to change the body's state of rest or motion. Okay, that's interesting. So, an action exerted on a body to change the state of rest or motion. Interesting. So, for example, when you throw, let's say you play baseball or volleyball or basketball, all right? When a ball goes up, it doesn't keep going up forever. It comes down because of gravity. Well, that's a force. Gravity is a force. Okay? So, an action exerted on the body in order to change the body's state of rest or motion. That is force. Okay? That's the definition. Now, it has a magnitude. So, magnitude is a number. All right? It's kind of like velocity. It has a number and a direction. All right? A number and direction. If you ever seen Despicable Me, Victor Vector, he's awesome. All right? So, it has a number and a direction. Okay? All right. Now Newton, Sir Isaac Newton. Sir Isaac is brilliant, and he there's so much he created in the science world, so many laws that we're going to focus on his three laws of motion. Okay, he created three laws of motion, and you probably heard of one, maybe two, maybe all three of these. Okay, so the first law, and if you already know these, you don't have to write them down, but if you want to write them down, that's fine. So the first law is an object will remain at rest or in motion unless acted upon by a force. Okay, an object will stay, the longer version, an object at rest will stay at rest, an object in motion will stay in motion unless acted on an outside force. I just kind of condensed it into this. So it's going to stay at rest unless a force is acting on it. All right, that kind of makes sense. So that your computer is going to stay on your desk unless there's a force that pushes it. All right. An object in motion stays in motion. Fascinating. The second law is literally this equation. You don't have to write all these words out. You don't have to write these words. It is literally force is equal to mass times acceleration. So the second law is just this equation right here. Force is equal to mass times acceleration. Like I said, this is a little different. This goes into more physics calculation, and we're not going to get to that. The equation is force is equal to mass times acceleration. Okay? And then the third law, for every action, there is an equal and opposite reaction. I feel like you could sing a song about this. I'll think of something. For every action, there's an equal and opposite reaction. Those are Newton's three laws of motion. Okay? For every action, there's an equal and opposite reaction. And if you need me to slow down at any point, or if you have a question at any point, please unmute yourself and ask. Let me know. All right? Well, just let me know. Okay? For every action, there's an equal and opposite reaction. All right? Just a little picture. All right, so net force. Now, net force is the combination of forces. You don't have to write this down. but it's a combination of forces. All right, so you might have two forces acting on an object. For example, if let's say you have a pencil and you have it in one hand and in the other hand, and you're pushing in on both sides. That's a net force. You're having two forces acting on it. Okay. And an object accelerates in the direction of the net force. So, for example, if we look at this first one, 10 newtons is being pulled to the left, 10 newtons is being pulled to the right. Well, if I combine those two, well, 10 to the left, 10 to the right, my net force is 0. Okay. If I look down here, I have two people are pulling on box. So 10 newtons pulling here, 10 newtons pulling here. My net force is 20 newtons going to the right? Because I would combine those two, and there's nothing pulling to the left. In the bottom example, I have 10 newtons pulling to the left, only 8 newtons pulling to the right. Well, if you combine these two, I have 10 going left, 8 going to the right. Combined, my net force is 2 going to the left, right? Because 8 newtons cancel on both sides, which leaves 2 newtons on this side. And that's what a net force is, okay? So net force is a combination of forces acting on an object. Okay, combination of forces acting on an object. Okay. All right, we're going to move on to a balanced force. So this top example is a balanced force, okay? That's what a balanced force would be, okay? So the result is a net force of 0, all right? So balanced forces are, for example, you sitting on a chair, all right? The chair is pushing up, you're sitting down, that doesn't move, right? So this means an object, it doesn't cause an object at rest to start moving or vice versa, or a change in motion of a moving object. So let's say both of you are pushing on a toy truck. That toy, if it's equal force, the truck's not moving, right? The net force is 0. Okay. Crazy. Okay. So balance force is the result in a net force of 0. So if everything's balanced, force is equal to 0. All right. And it does not cause an object at rest to start moving or change in motion of a moving object. Okay. So let's see. And so that's balanced. All right. So it's kind of like this box that's balanced. The other two are unbalanced because it's going to start moving. Okay. It changes it, right? When the net force is greater than 0, the object is going to accelerate. It's going to move. Okay. So if you're playing like tug of war here, whoever's pulling stronger, it's going to move that direction, right? Let's see. Another one. If you have 4 newtons, 2 people pulling to the right, 1 person pulling to the left here, I have a total of 8 newtons on going right. Well, this object is going to move to the right. All right. The seagull is going down, the rocket's going up. All right. Those are all unbalanced forces. So unbalanced means the object is going to move. Okay. That's what unbalanced forces mean. Object will move. All right. We're going to keep going. Now, there are other types of forces that we're going to kind of focus on, and the big one is friction. Okay, friction. So let's say you roll a ball, and eventually, and like on a road, it's going to roll, it's going to roll, it's going to roll, but eventually it's going to stop, and it's going to stop because of friction. All right. So friction is a force that opposes motion between two surfaces in contact. Okay, so that kind of makes sense. It opposes motion between two surfaces that are in contact. Yeah, that makes sense. But now there are subcategories of friction that we're going to talk about. First one is static. If two things are stationary, so for example, between your computer and your desk, that is static friction. All right. Neither one is moving. All right. Both of those are stationary. Uh, there's static friction between your desk, the leg of your desk to the floor, right? Neither one of those are moving. All right. That is static friction. Whereas kinetic friction, that occurs between moving surfaces. Okay. So that's that example between moving surfaces. So they both got to be moving. Okay. So that kind of makes sense between static and kinetic. Okay. It occurs between moving surfaces. Now, this can be three actually. So there's three forms of kinetic friction. There's three forms of kinetic friction. Sliding is one of the kinetics. Sliding means friction between two objects sliding past each other. Okay, well, that kind of makes sense. Two objects sliding past each other. Kinetic friction. Both of them are moving. Well, that kind of makes sense. Rolling. Friction between a round object rolling over a flat surface. All right, so this is an example of the ball rolling down the road. There's rolling friction. All right. What's another example you might be able to think of? Maybe maybe a car tire, right? Car tire would have rolling friction. All right. Those are all examples of rolling friction. So sliding friction slides, rolling friction rolls. Fluid friction is friction that of friction on any object moving through a fluid, like a liquid or an air. That's fluid friction. That's kind of hard to say. Say that 5 times fast. Fluid friction, fluid friction. Kind of hard. All right. So friction of any object moving through a fluid, including air. Okay. So friction opposes force, right? It slows us down. All right. And those are the different types of friction. Okay. So sliding, two objects slide, rolling, rolling, fluid occurs in a fluid. All right. Now, let's see. Is friction harmful or helpful? Well, it kind of depends, right? You don't have to write this down. You do not have to write this down. Some friction can be reduced, making objects streamlined or through the use of lubricants. Some friction is necessary, such as when driving a car. All right. So if you look at this, you want very little friction. If you're going skiing or snowboarding, if you stop all the time, that's not going to be that fun, right? But B, if you're running down a hill, well, yeah, you kind of want some friction to slow you down. All right. So it can be both. Friction can be helpful. It can make a right. It can help you out. Uh, or less friction might be able to help you out as well. So that is a summary of forces. Okay, that's force. How do we feel on force? So tomorrow, when you guys are doing a car experiment, you're gonna have car going down a little ramp. What friction would that be? Well, it's moving, so it's going to be one of the three kinetic frictions. It's going to be the rolling, right? It's going to be the rolling friction, all right? And that's what's going to eventually cause your car to stop, right? Your car isn't going to roll and roll and roll until it hits like a wall or something. It's going to stop before it gets there. And that's rolling friction, okay? So that's tomorrow. For today, what we're actually going to do is I got a little PhET activity that we're going to try out. And if you click on it, pulls you up the assignment. Okay. So this is what it kind of looks like. Okay. And the directions are pretty straightforward. It says run the PhET simulation by going to the link below and putting in. All right. So you can click on the link, and eventually the link will pull up this. And to start off, you're going to have some people playing tug of war. All right. And you're looking at the net force. Okay. Net force is key. So you might have this dude and a small dude versus the big guy. All right. And let's do I want all of these. Go. Okay. Each one is pulling 150 newtons, but it's not moving because they're both equal, right? So the sum of forces is 0. So what you're going to do down here is a combination. So you're going to create the combination for yourself. Now, if you want to edit this in Cami, you can. Or you can say I had on the left side, you had a medium and small. On the right, I had a large, right? Yep, medium, small, and on the right, I had a large. You can just say it in this box and then say what happened. So what happened? There was no movement. There was no movement. And that's what you can say, right? And the second question, are these balanced or unbalanced? Well, if the sum of forces is 0, it's balanced. Okay? And that's what you are doing. Okay? You'll try two more events, and then you'll go down to the friction. All right? So friction can be found right here. Okay, you're going to click on friction. And you're going to try some things. All right? Select the friction simulation on the main screen. Check the boxes. All right, so I got to check the boxes real quick. Okay, got all my boxes checked. Slide the friction bar all the way to lots. Slide the friction bar all the way to lots. Okay, did that. Record the sum force, top speed, and what happens. Okay, so when a 500 Newton force is applied. Okay, so I have to apply 500 Newtons. Okay, what's my top speed going to be? Oh, that's interesting. He let go of the box. I want to redo that. All right, what's my sum of forces? All right, what's my sum of forces? Well, my sum of forces is 312. Okay, so my sum of forces is 312. My top speed, I forgot to check what that was. My top speed was 30 something, I'm pretty sure, before the guy let go. 30, I think 40 actually. So my top speed was 40. Oh, didn't mean to go there. And what happened? Well, when he reached his top speed, he let go of the box. Oh, I guess that should go under the box, right? And what you're going to do is you're going to do that for different objects. You can have a girl. You can have a girl carrying a box. You can have a box on top of a trash can. And it only has 3. So you can have the guy holding the refrigerator sitting on a trash can. A little unique, okay? And fill in a few of these. Now, at the bottom, it says there's some questions, okay? Some questions that apply what you guys are looking at, okay? that is what we're doing today. Okay. You guys have the remainder of class period to work on that. If you guys want to work with a partner on that, that is absolutely fine. Just make sure both your names are on it. Uh, if you did not complete yesterday's activity, today would be a good idea to try to get that done as well. Does that sound like a plan? So try to complete the FET activity. If you guys have questions, I will stay on the Google Meet. You guys can always pop back in, ask any questions you might have. Uh, if not, the remainder 18 minutes is yours. Uh, and we'll see you guys tomorrow.